Hello students! In this video we are going to be doing some practice with SOL G10. I've got my notes here beside me that include some formulas or concepts I need to understand to move forward. So I'll have those handy. These would be great things to memorize, be able to brain dump as soon as you begin your test. All right, so let's see what we need here. It says, example 1, what is the measure of an interior angle of a decagon? Okay, so first of all, I need to make sure I know what I'm answering. I'm answering the measure of an interior angle. So that means one interior. One, not the sum of all of them. Next, I need to make sure I read this right. We're talking about a decagon, and I don't have a picture. So how many sides does a decagon have? Use that prefix to help you if you need to. Deca, that stands for 10 sides. I dare not try to draw a 10-sided figure. That will be a mess. So I'm going straight to the formula. The sum of interior angles is equal to 180 degrees times the number of sides minus 2. So let's start there. That would be 180 degrees times 10 minus 2. Use my calculator over here. That's 180 degrees times 8. 180 times 8 is 1,440. So the sum is equal to 1,440. Now we want to know one interior angle. One interior angle. So I'm going to take that one interior. We're going to take the sum of 1440 and divide it by the 10 angles, and that's going to give us one interior angle equal to 144 degrees. All right, remember, one interior would mean all the angles are the same. There are 10 angles. Take that sum divided by 10. Our next example says the sum of interior angles. The sum of interior angles. Okay, so sum, that's all of them, is 1,440 degrees. How many sides does the shape have? Well, we're really working this problem backwards. We already found that sum. So the sum of interior angles is 1,440 degrees. How many sides does the shape have? So that would be 1,440 degrees is equal to 180 degrees times the number of sides minus 2. Well, I'm going to take the approach to get rid of the 180 first, so I'm going to divide it away. I'll need some calculator help here. 1,440 divided by 180 is 8. So 8 is equal to n minus 2. Add 2 to both sides, and I'll get that n is equal to 10. So this is a 10-sided figure. Well, that confirms what we started with over here. Here we were told that we had a 10-sided figure, and we worked our way to the sum and eventually to one interior angle. Here we were given the sum, and we worked our way to the number of sides. See how we can use that same formula in a variety of ways. Okay, our next example says, what is the measure of an exterior angle of a polygon with 12 sides? There it is. We got to read it very carefully. An exterior angle. So we want one exterior angle. One exterior. Well, we know that the sum of all exterior angles for any polygon is 360 degrees. Now, if this polygon has 12 sides, it also has 12 exterior angles. So one exterior angle is going to equal the 360 degrees split into 12 parts. 360 degrees divided by 12 is 30. So one exterior angle is going to equal 30 degrees. In my final example here, the question reads, in a regular polygon, each exterior angle has a measure of 45 degrees. How many sides does the shape have? Read it very carefully. We are told that each exterior angle is 45 degrees. Now we know that the sum of exterior angles is 360 degrees. So one exterior angle is going to equal that 360 degrees divided by the number of sides, or number of angles, n. So if we're told that 45 degrees is one of the exterior angles, we need to solve for the number of sides. I'm going to do this in a cross multiply way. I'm going to drop a 1 underneath this 45. So I'll have 45 n is equal to 360 degrees. I need to divide by 45 on both sides to figure out what n is equal to. 360 divided by 45 is 8. So the number of sides is 8. This would be an octagon. Okay, now that was a little run through with no pictures. Next, we've got a series of examples that do have pictures, but one thing to notice about each of these is they're all a little bit different. We're just going to have to really unpack each question here. This next question says, what is the measure of angle 1? Now, something to notice about this pentagon, it's all lopsided. It's definitely not a regular pentagon. Each exterior angle has a different angle measure. However, what we do know is that the sum of every exterior angle of any pentagon or of any polygon at all is 360 degrees. So if we've already used up 90 degrees, and we've already used up 60 degrees, and we've already used 104 degrees, and we've already used 44 degrees, whatever is left after all that subtraction is going to be what's left for the measure of angle 1. 360 minus 90 minus 60 minus 104 minus 44 leaves me with 62 degrees. So the measure of angle 1 is equal to 62 degrees. In this next example, we don't have a full figure. Take a look. An exterior angle is shown in the picture. How many sides does the polygon have? Okay, now read it very carefully. It says an exterior angle. That's only one of the exterior angles. That means however many sides the shape has, every single exterior angle is 20 degrees. Well, I really think that this example problem is super similar to the fourth one up top. Here we say in a regular polygon, each exterior has an angle measure of 45 degrees. How many sides does the shape have? This just includes a picture, which makes it a little more visual. So we know that the sum of exteriors is 360 degrees. That means one of the exterior angles is going to be equal to 360 degrees split amongst all the angles in the shape. Well, here we have that 20 degrees is the measure of one of the exterior angles. So we're trying to solve for how many angles there are. I'm going to turn this into a cross multiply problem by putting a 1 underneath the 20. Cross multiply, I'll have 20n equals 360 degrees. Divide by 20 on both sides, and I'm going to get 18 sides to this polygon. No wonder that shape was not drawn out. That'd be a difficult shape to do. I've got 2 more examples for you here, and these next 2 examples are focused on tessellations. In the first example, it says, both the pentagon and the hexagon are regular polygons, meaning all 5 sides are the same, all 5 angles are the same, all 6 sides are the same, all 6 angles are the same. What's the measure of ICD? Angle ICD. So we're looking for this angle on the outside of the polygons. All right, so let's work in the pentagon first here. A pentagon has 5 sides. We can find the sum of interior angles with using the formula 180 degrees times the number of sides minus 2. Well, that would leave me with 540 degrees total for this pentagon. Now I need to split that up into 5 congruent angles. So one interior angle is going to equal 540 divided by the 5 angles. 540 divided by 5 is 108. So each of these interior angles in the pentagon is 108 degrees. I'm going to do the same work for the hexagon. The sum of the hexagon would be equal to 180 times 6 sides minus 2. So 180 times 4 is 720 degrees for the sum. But this time I have 6 angles that are all congruent to one another. So I need to take that 720 degrees and split it into 6 parts. So one interior angle will be 720 divided by 6, which is 120 degrees. So each of these interior angles on the hexagon is 120 degrees. Well, in order to answer the question that's being asked, I need to understand tessellations. I'm using point C here, and I know that the full rotation all the way around point C is 360 degrees. Well, I've already used 108 degrees for the pentagon and 120 degrees for the hexagon, so whatever's left out of that 360 degrees will be angle ICD. 360, subtract 108 and subtract 120 leaves me with 132 degrees for angle ICD. Not 1,000. Whoa, there we go, 132. Final example here. Another tessellation problem. Rectangular flower beds are built on each side of a fish pond that's in the shape of a regular hexagon. What's the value of x? Okay, well, I already know that rectangles have 90-degree angles. What I need to know is, what's the degree measure in this interior angle of the octagon? And then I can use that to help me find x. So I know that the sum of interior angles can be found using this formula, 180 degrees times the number of sides, which is 8 in an octagon minus 2. So 180 degrees times 6. The sum is 1,080 degrees. There are 8 interior angles of the octagon, so one interior angle of the octagon is 1,080 divided by 8. Leaving one interior angle to equal 135 degrees. So, around this point that has x, we have a total of 360 degrees of rotation. We've used 135 degrees on the octagon and 90 degrees on 2 of these rectangles. Whatever's left out of that full rotation will be angle x. 360 degrees minus 135 degrees minus the two 90-degree angles is going to leave us with 360 minus 135 minus 90 minus another 90 leaves us with a 45-degree angle for angle x. I hope this was a good refresher about the angles of a polygon. really, you need to spend some time committing these 2 facts to memory so that you'll be able to use them on your SOL. Happy studying!